Hello everyone, welcome to this video. In this video we shall see question from June 2014 consisting of 4.75 marks. The question says given y, which is defined on the half-closed interval 0 to infinity closed at 0. This function is continuously differentiable function. That means the function and its derivatives, they are continuous functions, right? And it satisfies this condition. That means this function is the solution of this integral equation. Then they are asking where this time is greater than the variable t is greater than or equal to 0. Then they are asking which among these four is true, right, for the given y. So for that, what you need to do, we firstly need to calculate the solution to this integral equation. Yt is equal to y naught minus integration from 0 to t ys ds, right? So this is our equation, integral equation. So now how to solve this equation? We do not have any information about y over here, right? The kernel here is just 1 and the parameter is also -1, right? And fx, this function is given to be y naught. So now we can solve this by differentiating this integral equation and then solving the obtained differential equation. So how to differentiate it? We can differentiate it with respect to t. So this first term becomes y dash t, that means the derivative of y with respect to t, and this being constant, this is equal to 0 minus now here we have to apply the Leibniz rule of integration. Leibniz rule. What does that rule say? If we had to do the integration, if we have to take the derivative of this integral 0 to t ys ds, then this would be equal to integration as such, the partial derivative with respect to t of ys ds plus the derivative of upper limit, that is t with respect to t, and this function y where s is being replaced now with t, y of t, minus the derivative of the lower limit, that is 0 divided by with respect to t, and this y calculated at the point 0, right? So it becomes now, because there is no t term, therefore this becomes 0, and here this thing becomes 1, therefore we only have y of t, and negative sign is because of this negative sign, right? And the derivative of 0 with respect to t would be 0. So we have y dash t as such, and here minus y of t. So this thing, or you can write this as this. So this is first order differential equation. We can simply solve it by the simplest method, the variable separable method, right? You can move all the terms corresponding to y on the left hand side and of t to the right hand side, and then we can integrate. So while integrating you'll get log of y, and integrating this you'll get minus t plus t, where c is the constant of integration, right? So now we have log, so and we are interested in calculating this y, so we can take the antilog or exponential, so we'll get y is equal to e to the power minus t plus c. Now it could be written as e to the power c into e to the power minus t. This thing we can call this as another constant, because c is constant, exponential of c would be constant, so this is constant. So we have y this. Now in order to have y, we must calculate what is this d, right? So for that we need some condition. In question you do not have any condition on this given y. So we what can we do? We can look at our yt, and we can calculate this y at 0. And why I have chosen 0 point? Because see, your interval is given from 0 to t, so your initial point is basically 0. So we can evaluate the value of y at the point 0. So that would simply be equal to y naught minus, here I have solved this over here, so it would be y of 0 would be y naught minus integration from 0 to 0 y of s ds. Now this integration would result in 0, therefore we have this initial condition, right? So now if you substitute this initial condition onto this function y of t, So it will be d into e to the power 0, that would simply be 1. So d would be equal to y naught, because y of 0 is equal to y naught. Therefore our function becomes this. Now for this solution, we must check which among these 4 is the correct option, right? So let us check it one by one. So first option is given to you, this one. So now we need to check for the left hand side and the right hand side. Left hand side is y square t, and what is y? Y is given to be y naught e to the power minus t, so its square would be this. And for the right hand side, see, this thing could be written as the whole square of this thing. True? No problem in that. So now we just have to replace the value, put the value of y. So we have y of t as this. Y of 0 would be, you just replace t with 0, right? So it would be y of 0 minus integration from 0 to t ys ds whole square. So we just replace this thing by y naught into e to the power 0 t, right? And it is equal to 1. And integration from 0 to t, what is ys? Ys this thing, but t replaced with s. So just perform the integration and then solve, you'll get this thing. Now you see, this left hand side is equivalent to right hand side, therefore this is the correct option. So option A is the correct option. Let us check for the other options as well. So let us see option B. Option B is again, left hand side is again equal to this thing, and right hand side we just check it. It is equivalent to, we'll substitute the initial condition. And here these terms as such, and the value of y as y naught e to the power minus s. Then we can solve this, perform the integration, put the limits, and then do the calculation, and this is the final result. Therefore you see, this quantity is not equivalent to this quantity, therefore this is not the correct option. For the third option, we have this thing, right? The left hand side is again this thing, y naught y square, that means this square, and here we have initial condition square, and then minus of integration of ys. Ys is y naught e to the power minus s. Again, this being constant comes out from the integration. You can perform the integration of this quantity. It would be e to the power minus s by minus 1, right? And then you can substitute the limits, you'll get this. Again, this thing is not equivalent to this, therefore this is not the correct option. Again, for the option D, you need to check whether this is equal to this or not. Here you can see the left hand side is again equal to this, and the right hand side, for that just again substitute the values. So y naught square is y naught square, and this thing is equivalent to this, because we just replace the value of the y over here, right? Do the integration, do the calculation, and you'll see the result as this. Now this quantity is not equal to this quantity. I'm sorry. This is basically y naught e to the power minus 2t. So this quantity is same as this quantity, right? Therefore we have this option as the correct option. So only option D along with option A are the correct, option B and C, they are the incorrect option. Well, that is it for this video. Thank you for watching.